Hey, how you doing, guys? It's Ilya Bella here. I record stuff on YouTube. Check the description for all my information. I do all LeetCode problems. Make sure you subscribe to the channel. Give me a big thumbs up to support it. And this is called all possible full binary trees. A full binary tree is a binary tree where each node has exactly 0 or 2 children. Return a list of all possible full binary trees with n nodes. Each element of the answer is the root node of one possible tree. Each node of each tree is the answer must have node.value is equal to 0. You may return the final list of trees in any order. Well, let's look at this example. We got 7 and we return this output right here. You know, this right here means like 0 0 0, right? Then null null, then again 0 0 right here, then again null null, right? And 0 and 0 right here. We can see that we got as well, we got 0 0 0, then we have null null, then 0 0 0 0, and 0 0 as well. Here we have a bunch of zeros. Here it's 0 0 0, then 0 0 null null, right? And null null 0 0 null null 0 0. N is greater than or equal to 1 and is less than or equal to 20. Well, I'll show you how to solve this problem recursively. We need to traverse through all the children and find all possible combinations. That's it. We can cache the results, right, at each level, and to do that we will be using map. We can put the value into that map which is associated with a particular key. We got the key which is the type integer and list of 3 node. It's called just map, new hash map. Again, we can copy that real quick. Integer list, the type integer. Yeah. Next, at each iteration, at each recursive call, all possible full binary trees, we check first. In the case when n modulo 2 is equal to 0, means that n is even, we return the result, which is the list of the type 3 node, the result new array list. There is nothing to do with that because, for example, when n is equal to 2, that means that we cannot generate a full binary tree because we got only 2 nodes, right? And we need to have at least 3 nodes or just the only 1 node, right? 0 or just 2 children, means only one node with no children at all, or just or 2 children right here. Next, in the case when we already found children at particular level, we can say if map dot contains the key, which is n, then we return this already computed result. We say map dot get, and we return the value, the list at the position of n. In the case when n is equal to 1, then we need to say result.add 0 and return this result. N minus minus because we are already at the root at each call, right? So we already counted this node. So say we just traverse its children here and here. We create a for loop int I, which is 1, I is less than n, and I plus plus. At each iteration we create the list of 3 node, which is the left, and we call this method recursively, all possible for all binary trees. We pass I, and right here we name it right, and we pass n minus I. We go left and we go right. We create another for loop, and we are looping through the children to your left, say left, and through the children to your right. 3 node right. And at each iteration you create a new 3 node, which is the current, which is equal to new 3 node. We pass 0, then we say current dot left is equal to L, and current dot right is equal to right. Finally we add this current to the result. Then we need to cache this already computed result. We say map dot put the current level, which is n, and let me check real quick. Yeah, like n nodes, and this result, and return this result. That's it. That's the whole problem. We use map right here in order to cache the results. We create a new array list, in the case when n is even, means has the tree has even number of nodes, we cannot come up with this solution. We just return the result right here. And in the case when we already know, we already computed you know, the nodes, the tree for n, we can get this result from that map. In the case when n is equal to 1, we add 0, we say, oh okay, we say new tree node, create a new tree node, and we pass 0 and we return this result. Then we say n minus minus because we already add the root at each, you can imagine this root right here of this tree, this root right here of this tree, and this root right here of this tree. And you can think of that this way. And then we iterate through all the children to your left and to your right, and we create, when we are at the bottom, we create a new tree node. We say current.left is equal to L and current.right is equal to R. Result.add the current and put that into our cache, into that map, and return the result. Let's run this code. Accepted. Let's submit. Success. Good. Thank you guys for watching. Leave your comments below. I want to know what you think. Follow me on social medias. I do all LeetCode problems. Follow me on Instagram, add me on Snapchat. Give me a big thumbs up to support my channel. Yeah, I think I explained it pretty good. That's pretty obvious what we're doing here. We just use the recursion, right? We go left, then we go right. We compute all possible combinations with that children, and we add that combinations to that result, right? And we return the output. I'll see you next time. Bye.